Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Let's see if this 1940s transmitter will come to life and actually transmit what kind of power we get out of it, and see if it'll make any noise. So let's get started. In the previous video regarding this forestry radio receiver and transmitter pair, we tested the receiver together, and the receiver, oddly enough, worked quite well with all of those old parts inside. So usually there is something wrong with them, a bad cap, bad resistor, bad tube, or something like that. In fact, I can't say that it perfectly worked. The BFO didn't work, so that beat frequency oscillator wasn't working well, but it received extremely well. It was very sensitive. So when it comes time to restore that radio receiver, things can only get better. That should be quite the hot receiver. Should work very, very well. Now, I didn't want to test the transmitter, which is this thing that you see right here, because this thing is, I guess you could say, well, it's had some very sketchy work done to it. So somebody's been in here and they've done some things that they should have done quite a bit better. So what I figure we'll do in this video is we'll attach this thing to a current limited power supply, and we'll bring the thing up slowly and see if this thing comes to life. Now, what I'm going to do is I'm going to attach the antenna terminal into my service monitor over here, so this will not radiate. What's going to happen is it's going to put the output power into a dummy load inside the service monitor, and we'll be able to see how much power this thing makes, and we'll be able to see if it modulates. So we'll be able to see if the mic input works on the front and if it would make any noise. So it should be a lot of fun in this video. So as seen in the previous video, this the PA plate tank tuning capacitor is so loose that it just, look at that, it just wants to go wherever it wants to go, and that will not work. So that needs to be fixed, and that can very easily be fixed by removing this knob and then just putting a tensioning washer underneath it for now. There is other ways of doing it. I'll show you this here, and that's a little trick, and you need to be very careful that you actually do the right thing, or you can damage the actual capacitor itself. So I'll tell you that little trick. So when these things get really loose, you can see how loose this thing is, right? So what I'll do is I'll zoom on in, and I'll move the focus over here so that we can see what's going on. Okay. So you'll see that there's a bunch of nuts in here. So all you basically do is remove this thing, right? So desolder a connection on the other side there, remove this thing, which we'll do when we restore this, and loosen up the nuts on this side. So there's one here and one on the other side, and all you do is you move this one nut right here. So I'll grab something, point to it here. This one nut here, give it about a quarter turn in. In a worst case scenario, a half a turn, and then you do the exact same thing with the one on the other side. The other side looks exactly the same. And what it does is it moves this ceramic wafer in ever so slightly, and that puts tension on the back side here of the rotor. And by doing that, what it does is it tightens things up. Now, you don't want to move this one, because if you move this one, you'll put the stator, the stationary portion of this capacitor, out of alignment. And what that'll do is that will cause these plates to touch these plates. They can't touch each other. This needs to move freely inside the stator. So the rotor has to move freely inside there. And you can see that there's a very small gap in there on each side. So by moving this in, all that's going to do is put just a little bit of tension on this. Now you have to be very careful. If you move these too much and you tighten this up on this side, you'll crack this ceramic wafer that's holding this little strip here that's going to put tension on this. Okay, so you need to keep that in mind. So only usually a quarter of a turn or something like that, maybe a half a turn at max, and that'll cause this thing to get very rigid. But for now, this is on the front portion here. I'll move this over a bit. On the front portion here, what I can do is remove this and just put a washer and a little, I guess you could call it a spring type washer in behind there. I'll show you what I'm going to do here, and that'll add a lot of tension to this just for now. So I'll go grab that stuff, and I'll remove the knob here, and I'll show you exactly how to do that. And this works very well if you don't want to actually go and do this. Here's one of those tempered spring type washers right here. You can see how it has a bit of a curve to it, and that is basically a piece of spring steel a very springy piece of steel. And what you do is you take 2 washers, put a washer on each side like so. And as you can see, it makes a little bit of a sandwich there. And if I squeeze this together, you can see how that puts tension on that. So at that point, what you do is I will grab a screwdriver here, just remove this like so. Usually these chicken head knobs have a recessed area, and this one actually has a very deep recessed area, so this will work very well. A lot of them aren't that recessed, but that'll work even better. So all you do is you take this, put 1 washer on here like so, you put the spring washer in between, put this other washer on top. So now you can see I've got this here, right? And you can see what that's going to do is that's going to pull this forward just a touch when I push the chicken head knob back onto the front here. So you can do this. Let's see. So we have this all the way this way. Okay, so what I'll do is I'll put this on like so. And then what I'm going to do is you can see I'm going to push this down. So I want to make sure this is where I want it. Okay, so like so, and that should be pointing at about 9 o'clock. I'll push that down like so, hold that, and then tighten that up. And look at that. Just like that, fixed. And that feels about the same as moving this around in the back side here. In fact, this might actually have just a bit more tension. And it doesn't affect the spacing. So the spacing of the capacitor will be just fine, as you can see. So look here, so nothing is shorting out. And that can be tested very easily with just a standard, ohm meter or continuity meter. All you do is you put 1 lead on the chassis and then 1 lead on this particular portion right here. And you can rotate this, and if it beeps or if you have any continuity, then you know that there is a short. It's pulled the plates forward, but usually that won't do that. So again, if there are issues with this and you need to move the stator portion of this capacitor around, you just loosen these nuts here and you can move this back and forth. And a lot of the times, if you do that, you're fiddling with this for quite a while. Now, I've seen these things so bad that people have bent the plates and they're shorting, and they're bent at different areas. So they're kind of bent on an angle, so you spend quite a long time straightening this out, but this is in very good condition, so this hasn't been tampered with at all. The spacing is pretty uniform throughout the travel. So there you go. That's nice and firm right now, so that'll stay where it needs to stay when we dip the plate there. All right, so when I said sketchiness, as I was talking about before, if you're just joining in now, look at this, how this is put together. Look at the line cord. The capacitor here on the bottom, I'll just move this down just a touch. The capacitor on the bottom is just black taped into the thing here. So there's, some pretty scary work. This capacitor just shoved into the hole on the top side of the chassis. This just moves around like so. So I'll just leave that in there like that. A whole bunch of taped off wires. Should be kind of fun to see if this thing does come to life. So what I'm going to do is I'm going to warm up the service monitor right here and get some cables hooked up. And let's see if we can get anything out of this transmitter. This should be a lot of fun. Okay, so the first thing that we want to do is turn on the service monitor, let this thing warm up for a while. All right, so it says we're on receiver test. We don't want it to be on receiver test. We want it to be on transmitter test. It's on FM. We don't want that. We want AM. And we can also move the filter around a little bit there, lower some of the noise into it. So let's see what else. Let's give it a scope display. That should be a lot of fun. So what this is going to tell us is we'll be able to see the frequency that this thing is transmitting on. So we can see how accurate that rock is in there still. We can see the power output, and if we feed modulation to this, we can see the mod frequency and level as well. So it gives us everything we need to see, and we can see what that mod looks like on the scope. So this should be a lot of fun, especially with all the hacked up wires and everything in here, like you see. Modulation transformer sketchiness going on right here. So should be a lot of fun to see how this thing comes to life. So what I'll do is I'll get this thing plugged in and we'll go from there. So what do you think's going to happen? You think it's going to make power output, or do you think it's going to do that in a form of smoke? Let's find out. All right, I've got everything attached here. I think that should be attached at this point. So this is my setup right here running into the service monitor. It's my slightly reactive. Might be a touch of reactance, and that's okay. We're good with reactance. Just a little bit of it anyways. So I've got this attached into here, and the power cord is now attached to the isolation transformer and current limited variac supply, which I will show you. So that's up here like so. So what I'm going to do now is I have the switch on the front of this thing. So I don't know if this is for the lamp, because I haven't traced the wiring. So I don't know if this is for the lamp or for something else, but this says on, so I'm thinking that it's either to shut this off or to turn this whole unit off. There's no switch on this, it doesn't seem, so that might be switched by the receiver. So anyways, this is in current limit right now, and we should get a dim glow out of this thing. It's in receive, by the way, the transmitter. One other thing I will show you. All this camera movement, pardon the camera movement. It's in receive, it's not in transmit, so if I put it into transmit, obviously it's going to draw heavy current. So I do not want that. And of course, if the power supply in this thing is toast, it's going to draw heavy current too. So here we go. On it is. And that's a little brighter than normal. So not too incredibly bright, but just a little bit brighter than normal. That's not making any difference. I'm moving that on-off switch around. So it's not making any difference there. So leave that in the on position. So this thing has metal tubes in it, so you can't see any tubes glow. There's no pilot light, so I don't know what's happening right now. Let's flip it into transmit for a second here. So I'll move this down on the bottom. Oh, yeah, it's definitely trying to transmit there. Okay, so this is what I'm doing. So I'm moving this around here. Like so, and as you can see, I'm getting a bit of needle deflection there, so it's trying to do something. So it's current limited right now, so what I'm going to do is I'm going to let this thing, I guess you could say, sit here and baste for a while. So hopefully the capacitors are not going to go bad. I'm going to let the caps come up slowly, so I'm going to let this thing sit just like this, and if the bulbs stay dim, I'm doing good. If they get bright, I'll let you know in a little bit here. So between this shot and the next shot will be about a half an hour of me letting this thing sit and just letting the capacitors get comfortable again. That's all. So I'll be right back. Okay, half an hour has gone past and the bulbs are still dim. So we'll be up here again. Bulbs dim. Good sign. I'll flip that switch into transmit again. Well, we still got action there, so it's drawing current, as you can see. And the bulbs aren't to full brightness, which is a good sign, so that tells me that most likely the caps are going to be okay. At least good enough for testing. Alright, so what I'm going to do is flip through switch, so it's going to bridge those bulbs out, and this thing is going to get full line. So here we go. Now this is still through an isolation transformer and current limited variac supply, so this is all still isolated right now. So the tubes themselves should come up. The filaments inside should be coming up to full brightness right now. And I'll flip this thing over to transmit and see what happens. Ho-ho, we got some pretty good plate current there, and the bulb is lighting up. So I don't know if you saw that. Look at that. It's doing things. All right. So let's see if I can get everything into where it needs to be. So what I'm going to do is I'm going to put the focus on the service monitor here, and maybe we can keep an eye on that. So okay, so the focus is on there, and I'll zoom in onto this here in just a moment. Let's see if I can dip this thing very quickly here and get some form of power output. So I'm going to flip this thing into transmit and see if I get it. Oh, I do have a dip. Doesn't want to stay in that dip. So it's looking to me like Look at that. So it's oscillating here. It's doing something. What does this do? I don't know. It's got power output. It is drawing quite a bit of current. And you can see the service monitor is moving around. So it looks like it's trying to parasitic oscillate or something in here. So I'll just shut this off for a moment. So what I'll do is, now there's an antenna tuning control inside here as well. So we have the plate control here and the antenna control, the antenna capacitor in the back here. So since this is going into a non-inductive load, that's really not going to do too incredibly much. What I will try to do is, let's see, so what I'm going to adjust is, oh, that popped off. That's not going to be a good thing for... Put that right back on. So what I'm going to do is try and move the antenna adjustment here just a little bit and see if I can stop this thing from oscillating. So it's not going to affect too much, but it might affect the oscillation. That neutralizing control on the underside of the chassis that I talked about in the previous video is probably way out of adjustment. So let's I'll just move this around a touch. So insulated screwdriver up here, but this is attached to the chassis anyways. So here we go. And let me just move that around a bit. Move that over to this side. And it still wants to take off. Yeah, you see it taking off. It just goes off to one side there. So it gets right to... You can see the bulb gets to a pretty bright state here. And then it wants to take off. So I'll just move this over to here and see if I can get a dip. Okay, so now what I'm going to do is, I'll turn this back on to receive here. So what I'll do is I will adjust the coupling between the oscillator and the drive, or the output tube here, the RF output tube. So now there's a good chance that that is hot with RF and B+, so I'm going to use an insulated screwdriver and come in from the top side, like so. Okay, so let's get this back over here so you can see what's going on and see if I can slow down that parasitic oscillation that's going on there. Okay, so here we go. And this is the one that I want to move, not the other one. Oh, still wants to take off. So there's multiple points that it wants to take off. And just kind of move it into a different spot. No. Okay, so now what I'll do is I'll adjust the actual crystal control, which is in the back over here. So I'll put this on to receive. I'll adjust this control back here, and we'll see what's going on. See if we can slow it down just a little bit by doing that. So what I'll do is I'll actually use something that's a little bit less. So this screwdriver here is insulated up here, and there's a little bit less metal. So and here we go. Let's try it again. So I'll put this in here in the back side. And I'll try moving this. Can I move it? It is. It will move. So let's try this out here. So do we have everything going on here? We do. Okay, so it's drawing pretty heavy current there. So I'll set that at 12 o'clock, about halfway, and I'll move this crystal control around just a touch. So even me poking this little piece of metal into there is causing it to do that. We're not getting a whole lot of power output now. So I'll shut this off for a moment and see if I can move this with a plastic end, which I can't because it's too big. So let's try this one. Get that right down in there. Is it going to move that without destroying my tool? Probably not. Let's try this one here, which is insulated. That one there. Okay, so let's try again. Here we go. And we got 5 watts coming out of this thing. And it's a little bit more stable right now. So you can see even me just putting this screwdriver in here is affecting it. And as you can see, it just wants to take off. And it wants to take off. So that could be a tube issue. It could be a fact that, you know, there's just so much, what would you call it, butchery under the chassis that it's just doing this. Everything on the top side is shielded here. What's towards the bench isn't. Sitting this on something metal might help that out, but this is still exposed when it's inside that case. The whole bottom portion is still exposed, and there's quite a bit of area between this and the receiver. Actually, no, not correct, because the receiver sits... No, that is right, because the receiver does sit on the bottom and this sits on top. So this is quite a bit of exposed area on the bottom, so that shouldn't be it. So I think that it might be a tube. Let's find out if I can adjust the coupling now that I've adjusted the crystal, and we'll see if we can make this slow down. I would like to be able to stick a screwdriver in here and move this with something insulated, but the problem is the this is so incredibly rigid that it's going to wreck my tuning tools. So yeah, that's just going to destroy my tuning tools. Give me a sec here. I'm going to look for another tool that might fit that. That'll be a little bit more insulated and not so incredibly conductive or magnetic. I'll be right back. All right, I managed to move this into a spot with this ceramic screwdriver. I had to be very careful because these things, they just chip and break. So I got that into a sweet spot where this wants to somewhat transmit without getting too... See, look at that. It's not doing too bad right now. Oh, it's still taking off a little bit. It's still trying to take off. It's kind of just doing this on its own. You see that? I wonder if one of these tubes is... Maybe that 6v6. Or it could even be a resistor or a capacitor that's going away under there. So anyways, we're getting about 7 watts now. Do you see that? I'll zoom on into this. It's about 7 watts coming out of this thing. So about 6.7 watts. I'll see. I'll just move this around a bit here to make sure it doesn't take off on me. Oh, I got 7.2. Taking off on me here. Nope. It's about 7.2. And I think that's just outside the dip. Oh, 7.3. So about 7 watts this thing is making. And it's holding somewhat stable now. I think it might be that 6v6 is being a little silly. So you can see that, what do we got for plate current going on? We got about 70 milliamps, 60, well, 70 milliamps, maybe 70 and a bit milliamps down here. Move this over here so you can see that kind of. So about 60, 70, 80, 75 milliamps, something like that happening in there. So not too bad. And as you can see the power output here. So is this the, no, I don't know what that on and off switch is for. Maybe modulation on and off, or maybe that's for the 0 beat. That might just turn on the oscillator portion of this thing so that you can 0 beat this into the receiver so that you can align the receiver and the transmitter. That might be that. Or that might even be an intermediate setting on the control down here. Let's back this out a bit on the control. So that might be the middle setting. So because this is receive, and then you need to be able to align the transmitter to the receiver so that you can get the receiver and the transmitter on the same frequency. So that might be this position. Or it might be this thing, so that might be to 0 beat the receiver into the transmitter. Again, unknown until I draw this thing up. Who knows, right? So I'm actually quite amazed that this thing is even making 7 watts and not making any smoke at this point. All right, so what I'm going to do now is I'm going to put a tone into the jack in the front here, and let's see if this thing will modulate at all. We'll be able to see that on the scope on the service monitor, which is just this thing right here. So I'll get that all set up and I'll be right back. as I was moving this thing around to attach the modulation to this thing, give it a bit of audio or put a tone through it at any rate, things really stabilized. So I'm thinking that's really odd. So I had my screwdriver and I thought it was a 6v6. And I knocked the 6v6 again and it started to get a bit unstable. So I thought, you know what, I'm going to knock the rock. So I did. I knocked the crystal a few times and everything just completely stabilized. So there's probably the connections inside the crystal are oxidized. So really what it is there's a crystal between basically two metal tabs in there and they're just pressed together. And you can see there's screws on the top side of the rock here. So I'll zoom on into that. You see right there down in the bottom corner of the screen, there's some screws on the top, so you can take these things apart and clean them up from time to time. Now again, this thing is going to be converted into the amateur radio bands, the ham radio bands. So this thing's going to go missing and chances are this thing's going to have a VFO on it at any rate. But just knocking it stabilized it enough that we can continue here, and it actually put the frequency quite a bit closer as well. So what I'll do is I'll move this out again and move the focus on the service monitor, pardon the movement of the camera there. So I'll put this into transmit mode, and it's nice and stable now, as you can see. Hardly any movement there at all, and you can see it runs in and out of the dip. So now, right in the dip, it's about, I would say, 6.3 watts or something like that, right in the dip. You see right here, and the frequency got quite a bit closer too after I knocked it, so it's at 3.315 now, where it was a little bit higher earlier. So it's very close to where it is, 3.315, 102, whatever. As you move this around and as things heat up, that's the last three are going to move around here just a bit. So what I'll do is I'll bring this just out of the dip. Now, as I mentioned in the previous video, you usually get maximum power outside the dip just a bit. And as you can see, I can get this thing up to about 11.4 watts or something like that now that the rock is working correctly. So you want to run this right in the dip. And of course, at that point, it'll modulate quite a bit easier as well. So right about there is the dip. So I'm not sure if we can even peak this thing up even better. I'll put this into the antenna capacitor here. And again, this is into a non-inductive load, so it's probably not going to make too much of a difference. I'll see, I'll bring this out of the dip. And let's move this around just a touch. Yeah, out of the dip, we can get about 12 watts. It's flickering about 12 watts completely with that one old 6L6 there. So I'll just leave it there. So, you know, not much of a difference. Again, it's, you know, into a non-inductive load, right? So, with my slight bit of added reactance over here. Let's see, what else can I say? Okay, so now it's about time to try and modulate this thing. So what I'm going to do is attach a tone to the microphone jack here, and we'll see what happens. So I'll get that all set up, and I will be right back. I have my cable attached to my low distortion audio signal generator over here, and this is also a signature tracer or curve tracer if you like. This is one of the projects that I released on Patreon quite some time ago. It's a $5, basically a junk oscilloscope that I picked up from a swap meet that I've turned into a curve tracer or signature tracer and an audio signal generator. So this is used for signature tracing, and it's also used for providing audio if you're working on guitar amplifiers or anything that needs some form of an audio drive signal. This is a low distortion source for that. So all the plans to build this thing and all the schematics and circuit board layouts and everything are all up on Patreon if you're interested in putting something like this together for yourself. Very handy tool to have around, and I use this thing all the time. That's why it's on the bench right here. So this little block that's plugged into it is protection. So what this does is this protects me from zapping the front end of the signature tracer / audio generator here. So if I make a mistake and I touch one of the leads of the cable here to something that's, you know, got a little bit of excessive voltage on it, it won't hurt this unit. It'll actually protect the unit and block that from going back in. The design and plans for this is also released up on Patreon if you're interested in building something like this for yourself. So what I'm going to do here is I'm going to attach this into circuit, and what I'm going to do is vary the audio gain control here, okay? So, another thing that this thing does is keeps this thing awake. So this will go asleep. That's another circuit board that's inside here, another design upon Patreon that will protect this old oscilloscope. So what it does is it pulls the trace off the screen if it's not in use for a short period of time. And then all you do is you just touch the leads together and it wakes it back up and everything comes, back onto the screen here. This keeps this awake for audio use as well. So it does a whole bunch of things. At any rate here, so what I'll do is I'll move this down here and I will show you where I'm about to attach this. So this is the microphone right here. Move the focus onto that. So this is the microphone input jack right here. And what I want to do is just find a comfortable ground here. So sometimes these jacks, when you pull the mic out, will ground out. This just floats. So the connection inside here is just floating. So with the mic in or mic out, the center conductor here is just floating. So what I'm going to do is I'm going to attach this in circuit without poking my hands in here, because this is a vacuum tube circuit and there is going to be high voltage around and I do not want to come across that. So I'll find a nice convenient ground in here. Right down here looks like a good one. I can get that on there. There it is. And I will attach this to the microphone input right here. I'm far enough away from everything at this point. And turn this thing on to transmit and see if we get any audio. So keep an eye on the service monitor. I'll move the focus over to that. And if it does do anything, I will zoom on in. Not really. I'll move the gain up and down. Now, there should be drive there. There is a lot of audio drive coming into this thing. So there's nothing going through that transformer in the front end. So this goes directly into a coupling transformer, or interstage transformer if you want to call it that, coupling transformer. And then that comes out of this wire here, and then will go into that potentiometer right there, as we can see. Comes right out of this wire. Goes into that potentiometer, and that goes into the grid of the 6C5. And that would be the wiper, which is right there, which goes to the 6C5. So what I'm going to do is I'm going to bypass that transformer and I'm going to go directly to the grid, and let's see if there's anything wrong with that transformer. So this is the RF line right here. So I want to try and keep this away from that. So this is de-energized right now. So I'm still going to use my pliers to get way down into the chassis here, because I definitely don't want to come across anything in this. I'm pretty sure the B plus is pretty high in here. You know what, just for the fun of it, let's see how much voltage is floating around in this chassis right now. Got a bunch of probes here off to the side. Hopefully this won't take me too long. I do. Okay, so turn this on. So this actually needs a little bit of time to warm up, but it'll be off by 0.3 of a volt. So I think I can live with that right now. So put this onto the chassis here. So ground that to that. Grab my other probe here. We're on DC volts, are we? We are. And let's see how many volts is on the rectifier. So any guesses? Let's see. What do we think? Maybe 450? Let's see. Well, I'm not seeing anything here. It needs to be transmit. There it is. 414. So there's 414 volts of B plus on that rectifier. So this is obviously switching the line to that, to the either maybe grounding a center tap or doing something at any rate to turn on the B plus over here. So it's the B plus is switched, and we just learned that right now. So there we go. That transformer has to be on because the tubes have to light up. So the chances are they're maybe removing the center tap or doing something like that at any rate. Who knows, maybe they're even switching it right at the high voltage level. I don't think they would, because it would probably arc in the switch. But yeah, you can see here, nothing. And then let's move the focus onto that there. Nothing, and then switch on. Yeah, about 414 volts. And that will move around. If I draw more current, we'll probably pull it down. See that? 399. Bring it out of the dip a bit. So the dip is It's the lowest amount of current that the final will be pulling right there. So there we go, 415 volts, something like that on that. So definitely don't want to be poking my hands around in that chassis, right? Come across that and I'll have a pretty bad day. Okay, so now the audio is hooked up to this thing, and it's hooked directly to the grid. So let's find out what's going on. And actually, I'm seeing something here. Let's see, move the horizontal together a bit. So we got 14% mod with a very low drive level. So I'll turn the drive up. It's modulating. So there's something not right with that interstage transformer. Somebody probably cooked it by putting something on the input. Look at that. It's modulating to pretty much 100% and it's clean. So turn that down. That's it changing ranges when you're seeing it do that there. Look at that. It's not too bad, you know. Not perfectly clean, but you know. There's a lot of stuff going on here. These caps are probably bad. Who knows what else is happening in here. So, it's right up to 100% mod. Switching ranges here, it can't deal with it. So there it is, 98%. So it's hitting 100% modulation. Just turn that down. Service monitor doesn't like that. So there you go. It's actually modulating. So an audio signal could be fed directly into the grid here if that interstage transformer wasn't needed. Again, that interstage transformer, I'll just turn this on to receive and move this out of here and put that back on to here. And as you can see, there's just nothing happening through that interstage transformer, right? So turn this back into transmit here, turn that back to receive, and move this right directly to the grid. So effectively, I'm just bridging out that transformer, going directly into the grid of the 65, and there you go, right? We have audio, right? So somebody probably attached something to this interstage transformer and maybe cooked it up or something like that, or maybe there's even something else in the circuit. Maybe there's some short somewhere else. It doesn't look like it, but who knows what's going on. So the interstage transformer could be changed. Could be so many different things. Might have had some other use and somebody's done something. Look at this thing, right? Who knows what's going on in here. So the bottom line is it works. And basically, if I wanted to, I could, throw another rock in here and put it on an AM frequency and just leave things the way they are, clean it up, of course, and use the thing. It's, modulating to 100%. You fix up the audio section, and away it goes. So technically, the receiver and the transmitter from that old forestry receiver and transmitter setup both work. From 1940 something or other. Pretty amazing. So I'm looking forward to the restoration of this, so definitely stay tuned for that. We'll restore the receiver and the transmitter and put it in the amateur or ham radio bands. That should be a lot of fun. Then we'll make some contacts together too. It'd be great. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. There'll be a lot of repairs, restoration, circuitry design, all sorts of things revolving around electronics, because that's what this channel is all about. So if you're interested in seeing more of this stuff, don't forget to tap the bell symbol and hit the subscribe button and do all that stuff that YouTube wants so that you'll get notified when I post a brand new video. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. Suitable for all levels and projects there for you to build and all sorts of neat information that you won't find anywhere else. Definitely check it out. I'll put the link just below the Show More tab, and I'll also post the link at the top of the comment section. So if you click on that, it'll take you right there. All right, until next time, take care. Bye for now.